So, a bottle containing a liquid taken from a refrigerator, placed in the room temperature at a constant rate. Room temperature is 20 degrees. As the liquid warms up, so means it's an increasing rate. Theta after time t is proportional to 20 minus theta. Okay, so this is what you can write. d theta dt is proportional to theta, 20 minus theta. Increasing, so hence d theta dt is equals to k. If it's increasing, you just say where k is positive constant. Alright. Now initially the temperature of liquid is 10 degrees and the rate of increase is 1 degrees per minute. So this whole ordeal here initially is where t equals to 0. The liquid taken out from the refrigerator is 10 degrees and it straight away increased at a rate of 1 degrees per minute. Okay, so right now, so when t equals to 0, theta equals to 10, and the increase of rate is 1 degree Celsius per minute. Okay, like that. Solve the DE and show the equation. Okay, solve by setting up a DE, solving it. Setting up and solving a DE, show that theta is this. Remember, you can actually substitute here, guys. Start this one inside this equation here. So this one will be times are here. So this will be 1 equals to k. Then sub 10 degrees. 20 minus 10. Okay. So this is your integral here. Now this is the careless mistake here that I think some of you already made. Remember of this guy here. This guy is very sly. -1. Integrate this, remember, divide by the coefficient of theta. I can be sure, like I can think half of the cohort will make this careless mistake. When you integrate this one, don't forget this is ln 20 minus theta divided by -1. Okay, so this -1 here is very important. Let me just write it down for you. Don't forget okay, so there you go. So goes to 1 over 10t plus c. Yeah, negative is the mother of all careless mistake. Okay. Don't think that because I'm at a I still do careless mistake if I'm not very careful with the negative. Okay. So same thing. Same with my professor at the university. Same thing. So just be very careful with the negative there. You don't really need to put the modulus for the ln if you do not want to, because 20 minus theta is definitely more than 0. But if you want to, also can. Doesn't really matter. This is it. Okay. Then you sub in the boundary value lah, initial value. 0 and 10. Okay. So I think this second part is quite okay. Find a time. So what is T when temperature is 15 degrees? Okay, even if you cannot do this part, you can just use this. You can do it. So thing. Okay. So negative can bring up. So this is 10 ln 2. 10 ln 2 minutes. Okay, so just leave it at 10 ln 2 minutes, okay? Remember this logarithm, this one can fly up. Say what happens to theta for very large variability. So as t goes to infinity, t goes to infinity, you have to know that e1 minus 10t. This is a negative value, the negative power here. Okay, this one. If you're not very sure, this is what you do, guys. Cheat code. Just bring a calculator. Key in whatever you want to key, like 20 minus e to the power of 10 e to the power of negative 1 million. You won't go wrong one. Be like 20. Okay, anyway, you should know that this one, you have to know this goes to 0. So hence theta will approach to, I mean, intuitively so that it would approach to room temperature ma. If this one don't approach the room temperature, I don't know what law of physics it obeys really. So it should be room temperature, right? So for very large, so as values e, the will tend to, okay, and then draw the graph of theta against t. So similarly, like I say, usually what you do is you just draw the, know what you're dealing with. So this is like 20 minus 10, right? So 20 minus 10e minus x over 10. Okay, just key this in. Make sure you understand that the asymptote is 20, and then your window value, please know that it's above. So window value, change it 0 to 10 maybe, y axis maybe put 30. Okay, is like that. Okay, so I mean I've repeated this many times, so just to recap, remember put your horizontal asymptote. Y equals to 20. So this is theta, this is t, 10 degrees. Like that. Sketch the graph. and press catch nicely. Okay.